Hello, students. At a quick question group from someone about 6.2. So I'm going to throw in a little white space here because I think the first one was about number 1. And it said number 1, part D especially. So something where the denominators have variables, maybe. I'm guessing. So let's see if we had something like this. Let's check. So go ahead and just write out what you have right now. 3 over 2 x squared y squared plus 5 over 2x y squared plus 7 over x squared y. So again, as you're looking at this, because we're going to perform additions and subtractions, we need a common denominator. And so if you take a look, the denominator is going to have the least common multiple of all of these components. So if you just kind of think of each of these kind of having exponents, remember the LCM will be the biggest of all of those. So the least common multiple, least common multiple is going to have a 2. Is the biggest, that's the least, it has to be a common multiple, so it has to have the highest of that. Then I have an x squared in this one. I have an x squared here, which is great, and then I have just an x. So I need an x squared. And then I have a y squared, and a y, which means I need a y squared. So this is the least common multiple, which would also be known as the least common denominator. Okay, so don't get confused when they say LCD, least common denominator, they really mean the least common multiple of the denominators. Okay, so just making sure that's clear. So now this is my LCM. So you can figure out what do I need to FLOF with. So if I take a look, 2x squared y squared, 2x squared y squared, the first entire term is perfectly fine. I don't need to do anything to it because it has an x squared y squared. Next one, if I look here, I have a 5, I have a 2, so that checks. I have a y squared, checks, and I have only one x. So this one needs, and I'll put that up here on the top, this one needs to be multiplied by x and x. So if I write that down, this becomes plus 5x over 2x squared y squared. And the last piece is a 7. Now let's take a look at this one clearly because this one might be a little bit different. Let's see, it has an x squared. That's great. It has a y, so I need another y so that I have y squared. Again, that's the portion here. And I also need a 2. This one doesn't have a 2 in it. So I need to multiply by 2 as well. And at the end of all that, now my denominator will have 2x squared y squared. The numerator will be 7 times 2, which is 14 times y. So now just combine all of that together because I have a common denominator, 2x squared y squared. And what I end up with is a -3 plus the 5x plus 14y. And that would be your final result. There you go. Okay. Let's see here. So I think that was it for, at least for the first group of questions. So let's jump to the second group, which is MC, and it was MC number 7. And it says, explain whether each of the properties holds for subtraction of rational numbers. Okay. So let's see here. If I subtract two rational numbers, will I always get a rational number? And yeah, so we got closure. Commutativity, we should already know that one, right? A minus B, is that the same as B minus A? And similar for the associative property. Let's take a look at identity and inverse. And let me grab a little bit of white space just to throw on the screen so I don't get too hung up. So we're going to really be focusing on identity and inverse. Okay. So remember, an identity is, if you go back to where we first saw it, which was back in chapter 3, the identity property, or maybe a little bit back in 2, but the identity property said for addition or subtraction would be, I need to find a number that I can do this with. Okay. So this is what it takes. You have to find a number that you can add and keep the same value. That's what we're doing right here, keeping the same value. And so again, it has to work on both sides. So for identity, if you think, aha, a minus 0 is equal to a, I'm gonna say absolutely, you nailed that. But just realize it actually has to be on both sides. Is this equal to 0 minus a? And that's where, unfortunately, the sad face comes in. Sorry, it is not the same because 0 minus a is the opposite of a. Okay, and that's not the same as what we have over here. So there's kind of a reason why it does not. And the inverse property, okay, so is there a subtractive inverse property? So that means I would have to start with a number, subtract something, and get back to 0. Okay. At the same time that I'm thinking of box. Yeah, I think that's the inverse. I gotta check. I think that one has to go both sides as well. But yeah, so in the first step, you want to think, oh, well, hey, is there an inverse piece here? And a minus itself does get me to 0. So is there an inverse for everything with subtraction? So then if you, so just again, see the difference here. The identity, both sides here, and the inverse is a little bit different because again, it's the piece that gets you back to 0. Now, one thing to consider that you have to be kind of careful with is that, that's the best way for me to put this. Let's go to addition because the addition one does work, and then I'll try to illustrate the probably my concern. So with addition, is there a number that we get to that makes this work out? And hopefully most of you would say yes, 0. Okay, so 0 is the additive identity. Okay, so now that 0 is what you have to get when you do the inverse. So I mentioned in class, we have an inverse, which is unique. We would be saying a plus something has to get me back to this value. Okay. Now we know for addition that this box would be represented as the opposite of a. So when you come back up here to check the subtraction, we had this unfortunate sad face, and the sad face came because what you can see is that there is no identity. If there's no identity, then this thing right here that I said was 0, because we think of subtraction being having the same identity as addition, and the issue is there is no identity. So again, you have to have this subtract to get you the identity. The identity is the value at the end. Down here in addition, this is the identity. Okay, so since there is no identity, that's part D, then you have no idea what it's supposed to be equal to. Now you might be thinking, oh, I could make it equal to the identity I'm thinking of, but the identity you're thinking of is the additive identity, not the subtraction one. So this one is a little bit more about kind of the terminology and understanding how they fit together, probably part E. So part E does fail, but it fails because part D failed. And so that would be a little bit of a difference. Now, as we get more into rational numbers, you'll be thinking about, hey, can I ever multiply by something and get back to my multiplicative identity? And that multiplicative identity is 1. Multiplicative identity is 1. So now we're going to do something very similar, and instead of the opposite of a, we'll have something that looks like this, kind of a raised to the minus 1. You may think of it as 1 over a, but instead of the opposite, we often refer to this as the reciprocal. The reciprocal is a slang word that means multiplicative identity, whereas the opposite is the slang term that means the additive inverse. So multiplicative inverse up here, additive inverse down here. Okay, and so yeah, that's why when you get to like a number 2, you would multiply by 1/2, the reciprocal. If you had the number 3/4, you would multiply by 4/3. And again, that would get you back to the number 1. So there you have it. Hopefully that clears that up just a bit. And if you have other questions, let me know. For now, off you go.